we came to know that in matrices we are dealing vectors. Basically, vector and matrix are similar things. Okay, vector is representing one problem or one equation, but we will have similar equation in a huge number, then we will make a matrix. For example, today I will present in a very simplest formation so that you can digest it very easily and concluded that linear algebra is nothing except the games of nerves. You need to know how to play with it. Yes. For example, you are visiting some shop, fruit shop, you are buying two apples, A represent apples, 2 represent 2, like A plus A, 2 apples. Similarly, you are buying 3 bananas and you are paying total sum in cash to shopkeeper 80 rupee, $80, 80 euro, whatsoever. But this is the one problem, one equation. Problem is what in it? You don't know how much charge, shopkeeper charge, what value for apple, you want to know. And you want to know how much he charged for banana. This is the problem that cumulative sum shopkeeper charged from you in form of 80, but you want to know what the value of individual element. Apple, banana, there can be hundreds of elements, okay, hundreds of fruits, hundreds of things. A moment ago I demonstrated in front of you people about some Russian example that if you want to buy or you want to get a house on rent, you will visit different houses. You will observe the first house, then it will become a first equation. Then you will visit to the second house, you will get a second equation. This is for what? For predicting the exact, or you can say almost appropriate or the better accurate value of the house in that area. Similarly, if you want to buy these fruits from some Islamabad, some market, you want to know that this shopkeeper is playing some trick with me or the price is almost similar like this. Then what will you do? You will visit some another shop. And for example, you want to ask what will be the price of 10 apple plus, this is some kind of a deal, okay? And 1 banana on some shop, then shopkeeper charge you 130. Okay, $130 whatsoever. This is the thing. For better accuracy, for high precision, you will visit maybe 10 or 20 or maybe 100 shops. But due to shortage of time, you want to analyze that what is the price. Then you will say this is sufficient. Is it okay or not?
Yes.
And of course, 2 equations for 2 variables are sufficient for the moment. So my children, very simply, you will make a matrix formulation from this, like 2a, 3, 10, 1, a, b, 80, 130. With the help of Cramer rule, with the help of Gaussian elimination, with the help of reduced echelon form, okay, you can get the value of A and B. This is a solution set.
Yes.
Is it really difficult?
No.
No, sir. So I don't need to teach you about linear algebra because things are very simple.
Yes,
Now very much clear to you people.
Yes, sir.
Important thing, you know how to compose the real life problem in form of equations. Mathematics. One another thing, I taught to people about the inverse. Inverse, we know how to find it. But what's the application of inverse? For example, There are tons of applications. Today I will talk about just cryptography. Cryptography is telling us how to encrypt the data. For what to encrypt the data? For example, if you are working in some forces, defense forces, you want to share some information with your colleagues, with your fellows at the border area against some enemy, you want to talk, you want to send them some message. If you will say, let's, for example, meet tomorrow, then they will know tomorrow chief will meet with some of their personals, then things become dangerous. So, on the call, or you want to send this message in form of encryption. The simplest formation of encryption, we can make it here like meet tomorrow, like with the help of alphabets arrangement. As we know, there are 26 alphabets in the English. Okay, A, B, C, Y, Z. So 1, 2, 3, 25, 26. If we want to replicate meet tomorrow by considering, because computer follow the what? Numerical values.
Binaries.
Okay? Binaries are whatsoever digital integer values. You need to transform your message in form of numeric data. So you can write here M13 E5 5 20 20 O 5 15 13 15 18 18 15 23. This is what? This is simple. Okay, you will become clever. You know what alphabet is the, yes please.
सर 10th में भी पता था ऐसे ही होता है.
Brilliant.
अगर हमें पता है
Yes.
जो encrypt कर रहा है उसको नहीं पता.
Brilliant. This is the thing. Of course, intruders, spy will encrypt the message very easily. Okay, they will. This is the thing. You are very genius. Okay, yeah. I am facing the genius people and genius people everywhere. Okay, so they will encrypt the message. They will know the information. Then what you will do, you will encrypt this message, this value. Okay, you need to, for example, you can make it a matrix vector formation. It can be make, okay, big huge sentence, or you can say make into the small vector values. For example, I am making the vector value. In each vector I am considering the 3 elements. Here, ignore the space. Ignore the space. People who are familiar are, okay, in Urdu, are we using some space?
No.
No, we can read the alphabets. Oh, it's in words?
Sir. Yes.
Yes, similarly in English, don't worry about the spaces. Okay, expert native speaker can read it, even without spaces. So, we are making a vectors arrangement. Each vector, okay, first vector, each vector will contain 3 elements, 13, 5, 5, suppose x1, 20, 20, 15, x2, 13, 15, 18, x3, 18, 15, 23, x4. If we will send these vectors, okay, from origin to destination point, intruder spy will easily observe it. Then what is the message? He will encrypt it. He will understand it. So we need to encrypt it in complication formation. Okay, from meaningful message to the meaningless. The metadata kind of thing. What we need to consider some key metrics. We need to develop some key metrics which should be familiar at the destination point as well as the transmitter end. Okay, transmitter end and receiver end will have the same key, benchmark key. Okay, so let's suppose some key metrics, because there are 3 elements in one vector, so we are supposing the matrix with 3 by 3, so it can be easily multiplied. For example, some matrix 1 2 3 1 1 2 0 1 2. This is a key matrix. Okay, so you need to multiply this matrix with x1, x2, x3, x4. Basically, this is kind of a transformation. Transformation, you are transforming some data. And transforming is in mathematics, they are using the word L for transformation purpose. Transfer from one form to another form, okay? So, what you will do, you will transform this data. Remember, how many rows there are?
3.
3. You will transform this data 3 to 3. So, an intruder or spy will not judge it. Okay, it look like same kind of stuff. And after transformation, for example, you are this one, your first transformation. Then what you will do? You multiply matrix A with x1. Similarly, second transformation, you will multiply A with x2. Third transformation, you will multiply A with x3. x4 transformation, AX4.
So ये मैट्रिक्स कोई भी हो सकता है.
It is kind of a random matrix. It is a key matrix. No one should know it. Okay? It is some kind of a secret information. Okay. So, because you can consider any value in it.
Yes.
Maybe 500, maybe 10,000, whatsoever. Maybe negative value, whatsoever you can consider it. So, for getting this transformed vector, this is kind of a new transformed vector. Multiply 1, 2, 3, 1, 1, 2, 0, 1, 2, and your first x1, 13, 5, 5. After multiplication, row into column, okay, you can say 13 plus 10 plus 15.
13
Here, 13
plus 5
plus 5 plus 10. 0
plus 5
plus 5
plus
plus
10.
10. My children, you are, okay, vector
38
38,
28, 15.
15. This is your transformed vector, Lx1. Similarly, you can get a transformed vector, Lx2, by multiplying with this matrix A with next vector, what you can say 20, 20, 15, and you will get 105, 70, 50. Similarly, you are this third, okay, here your key matrix A is the same. Remember, it is the same like this: 1, 2, 3, 1, 1, 2, 0, 1, 2. You are multiplying with third vector, and your third vector is 13, 15, 18, and after multiplication, you will get here 97, 64, 51. Similarly, you will get L4, the fourth transformation. Same, you will multiply with matrix A, fourth vector, 18, 15, 23, and you will get a transformed vector 117, 79, 61. This is, okay, Lx1, Lx2, Lx3, Lx4. These are new 4 vectors. You will send it like a message. This is encoded message. Okay, at the receiving end, what will receiver, or you can say your fellow will do? They will decode it, decrypt it. How? They will get x1, original one. How? By multiplying A inverse. You studied how to get the A inverse. If you have some matrix A, you can get A inverse.
Yes.
You will multiply just simple Lx1. I determine the value of A inverse is kind of 0, 1 minus 1, 2 minus 2 minus 1, minus 1, 1, 1. You are multiplying this vector.
38.
Yes, please.
38.
38,
28.
28,
15.
15. My children, it's very simple. You will get
Original matrix.
0 plus 28 minus 15.
A set matrix.
What is this? 72. Okay, 76. Minus 56. Minus 15. And here you will multiply with it. Minus 38
Plus 28.
plus 28
Plus 15.
plus 15. My children, you will get what? Could you please help me out?
13.
13, 5, 5.
Wow, sir, you are genius.
This is the thing, okay? Just enjoy. I know you people are genius, okay? So, the beauty of A inverse, study the things, okay? There are huge applications. You can use it. Until there is no traitor, no one can get it, what is going on.
Yes.
If someone is traitor among your team, then of course this key matrix can be leaked out. Otherwise, key matrix is some kind of a secret thing which should be known at the destination as well as at the transmitted end, so no one can know about it. You can encrypt the data safely and you can send it. Then of course, meet tomorrow is possible.
Yes.
Okay? Actually, I don't need to teach you people. Sometimes I embarrass to whom I am teaching. You people are genius, okay? Really?
Then why we need to come to you?
Actually, you are wasting your time. Okay? Turn it off. Turn it off.